Okay, why don't we get started? So thanks for joining today's Linux Foundation Decentralized Trust online meetup. Today we have Alvaro Picazo. We'll be speaking about deploying Besu with privacy enabled on the cloud using Hyperledger Bevel. And with that, Alvaro, take it away.
Thank you, David. So, yeah, hello everyone. Should I start now, or should I wait a couple of minutes still to let more
Um,
people in?
you're welcome to wait a second if you'd like, but I think
Sure.
people will be joining here in a minute.
Okay, let me know then.
I mean, one thing we could do with a smaller group at first is just maybe go around and have people introduce themselves, see what their interest is in Bezu and Bevel. If you want to introduce yourself, and then maybe invite the other people to do the same.
All right, yeah. So, my name is Alvaro Picazo. I'm a software engineer. I work at Accenture, and I'm a Hyperledger Bevel maintainer and Decentralized Trust Labs steward. And for today's meetup, we're gonna be deploying a Besu network with privacy enabled on the cloud, important on the cloud using Hyperledger Bevel. So, yeah, with this said, if anyone wants to introduce themselves, feel free to do so.
Yeah, Antonio and Panagiotis, it'd be great to hear more about your interest and what you're looking to get out of this meetup, so we can make sure we give you what you're hoping to learn.
Yeah, hello, my name is Pano. I work for Talent Protocol. I'm a senior Web2 software engineer. I have recently joined Web3 company 9 months ago. So I'm quite new to blockchain and related technologies. Um, we at our company we are looking at moving to private blockchains. So that's why I'm trying to catch up and level up little by little on Hyperledger.
Mm-hmm. That's great. Yeah, Hyperledger Bevel actually is a pretty cool tool to deploy or for developers to use it and deploy private blockchains on the cloud. So glad you're here.
Thank you.
Great. And for the people who've just joined, we were just doing a quick set of introductions. So before we get started on the presentation, if you'd like to just introduce yourself and say what you're looking to learn today about Bezu and Bevel or anything else, that you're welcome to do so. So feel free, Antonio or Jeet or Trevor or Alfonso.
Mhm. Hello.
Hi.
All right.
Yeah,
Well,
hello. Can you hear me?
hello. Yep.
Yeah, this is Antonio. Sorry, but I still working, so I remain in background. Well, we are working in some proof of concepts involving several technologies based on blockchain. Having in mind the immutability, thinking not only the public, also the private ones. So maybe getting knowledge in this hyperledger with Besu and the deployment. Also with the privacy enabled, that is one of the tricky that we could gain knowledge today. So basically, this is the status of our pilots and still getting knowledge. Hyperledger as a private one of the candidates to implement something in the private. Okay.
Yeah, yeah, that's great. Actually, I think privacy enabled was a point that would catch many people's attention. So yeah, it's great to have you all here.
Great. Well, if anybody else would like to introduce themselves, feel free. Or Alvaro, you're welcome to, start your presentation.
Mhm. Okay, thank you. Yeah, yeah, I'm ready to start a meetup. Yeah. So what we will cover today is, well, I'll make a brief introduction to Hyperledger Bevel. We're gonna deploy the different Besu network components on the cloud using the latest Bevel Helm charts. Alongside the Besu nodes, we're gonna be deploying Tessera as the privacy manager. I wanna to mention here that as of today, Tessera is the privacy manager we support in Hyperledger Bevel, but I will for wrapping up the meetup, I will talk you guys about the newest privacy solutions we have in the labs and that are coming strong, and they're worth mentioning. And for testing the privacy feature, we're going to be deploying a very basic smart contract, and we're going to submit a few transactions between some entities to see which entities can see what. So yeah, with this said, Hyperledger Bevel is an automation framework for rapidly and consistently deploy production-ready DLT platforms on your Kubernetes cluster. We currently support EKS, AKS, or even GCP. So Accenture developed, tested, and open source Hyperledger Bevel under the Decentralized Trust ecosystem, and it allows developers to set up in a secure way a blockchain solution with their DLT platform of choice. Currently, the ones we support are Hyperledger Indy, Corda, Besu, Fabric, Quorum, and Substrate, which was our latest addition. So Bevel, some of the key features here. Bevel helps, or actually, yeah, helps the developer to save a lot of time in configuring the network components of a blockchain network. Thanks to our automation files and Helm charts. So from the release 1.1, we've made Hyperledger Bevel more of a Helm charts repository because as of the feedback from the community, it was that Bevel initially needed a lot of prerequisites. So one of them was Ansible, which is an automation tool. We used to use it to if we go to the image on the right, if you see here, we have a configuration file in which you set DLT platforms you want to use, the consensus or different organization details that are going to be part of the network. So Hyperledger Bevel, using its automation files and Helm charts, will deploy the DLT of choice on the cloud. The thing is that some developers that were using Windows found it difficult to use Ansible on their machines. So we decided to kind of separate the Helm charts and create another way of deploying a DLT platform on the cloud with just running the Helm charts basically. So this gave the developer a lot of flexibility. So they don't need all of these prerequisites to be installed in their machines. Also, as for today's demo, I'm going to be using HashiCorp Vault as our secrets manager, and I'm going to be using as an ambassador as well to make it the demo as more realistic as possible. But you don't necessarily need to use these tools to deploy a DLT platform on your cloud environment. You have two different ways of using the Helm charts to deploy a DLT network that we will see later on. But one is with using HashiCorp Vault and Ambassador, and the other one is without using HashiCorp Vault and Ambassador. But we still have the security feature there. So our Helm charts are when we deploy, or when the network components are deployed, crypto materials are generated, and these crypto materials are securely saved in my case, because I'll be using HashiCorp Vault, they will be securely stored there. But if you don't want to use HashiCorp Vault, we support some native tools from the cloud, such as AWS Secrets Manager or AKS Vault, or even you can store the crypto materials in the Kubernetes secrets. And yeah, these are basically the key features. So this, I'm going to jump into the scenario that we're going to have for this demo. In this case, I'm going to be using just one EKS cluster hosted on Amazon. In a more realistic scenario, each entity will be hosting their own Kubernetes cluster, where they will deploy probably a Vault instance and their network components. But for this case, just using one Kubernetes cluster will do the work. We don't need to have it as that much decentralized. So we will have 4 validator nodes, because we're going to be using QBFT consensus. So the minimum number of validator nodes are 4. I've mentioned already that I'm going to use a HashiCorp Vault as the storage tool, and Ambassador. So I'm going to be giving real URLs to the different network components to make it as I said, as more realistic as possible. And here we're going to have 3 different entities or participants, organizations, however you want to call it. And each of them are going to have a Besu node and a Tessera node attached to it. So the reason why we're going to have 3 is because I want to submit transactions between, let's say, entity 1 and entity 2, and I want to exclude entity 3. So we will be seeing what entity 3 can see and what cannot see, and the ones that were part of these private transactions, what can they see. So I think we're ready to jump into the source code now. Let me know if you can still see my screen. I guess you can, but is it big enough, or do you want me to zoom in a little bit? I think you can read it, but if someone could tell me if it's big enough.
A little small, but it's readable.
A little small. All right, let me get a little bit bigger. All right, so this is the Bevel source code. So here we have folder called platforms, and here we have a folder for each of the DLT we support. So I'm going to open Hyperledger Besu, as we will be deploying a Besu network, private Besu network. So here we have the charts folder. So we're going to be following the README file, right? Which gives you a walkthrough of how to deploy all the network components you need to have a production-ready DLT network. So first of all, it tells you that you need some prerequisites, just some Helm dependency, because our Helm charts use some dependencies. So you might need to run these commands. It's pretty straightforward, actually. So Here we have without vault and proxy section. We're not gonna be following this because I aim to use vault and ambassadors. So I'm gonna jump into the line 71, which is the guide for ambassador, proxy, and vault. I want to mention here that our main topic is privacy, and as this takes some time to deploy, I have already deployed the validators and 2 nodes for 2 entities. I still have to deploy the third node for the third entity, so I'll be following these steps. But if you are new to the technology, some of Bevel maintainers, Sonak and Subhajit, have done a couple of webinars in which they deploy all the validators step by step, and they explain it very well. How do they look like, and it's a great guide done by them. So I recommend you to go to our YouTube channel. You'll have them then there uploaded. But yeah, just followed these steps, right? And I'm gonna jump directly to set up another member in a different namespace. So if I go here, I have these different namespaces. I have entity 1, entity 2, and validators. So for the entity 1, I have a Besu node, this one, and a Tessera node. These are some jobs related to the Besu Genesis that we will run later for the third participant, but the same for this. This is the same for entity 2, and in the validator namespace, we have the 4 validators up and running now in the network. So if I do a Besu node, if I check the logs from the validators, we should see, I'm gonna open it up. So they are mining blocks. They're mining empty blocks because I'm not sending any transactions to the blockchain yet. But we see that the latest imported block was block number 684. Currently, the number of peers, it's 6. It's not counting it itself, so it says 5, but in total we have 6. So with this said, I'm gonna now deploy a Besu node and a Tessera node for the entity number 3, which is not which doesn't exist in our network yet. So the first thing we have to do is go to the Besu Genesis folder files, and we have to run these commands. Here basically what we're doing is we're getting the statics nodes file from the config map from entity 2, which is stored there, and as well the Genesis file that we will be using for the best node to be deployed. Here, I think I have not set any boot node in this current network, so I guess this file will be empty, but we're gonna check it now. So if I show you guys the Genesis file, this is the Genesis we're gonna use. For creating the Genesis file, we have some templates. I'll show you later how we do it in our Helm charts. And in the static nodes, I have the 4 validators listed here, and the 2 nodes for the 2 different entities that are already there in the network. So now it tells us to create well, tell us to go to the root folder, which is the charts folder, and create the namespace for entity 3. We're going to create it, and we are going to create the root token because the health charts that we're going to run store the crypto materials in my HashiCorp Vault instance. So it needs a root token for this, right? So now we have to run the Besu Genesis Helm chart. So we are setting here the namespace, and we're passing as an argument a values file. So if you remember, I told you that you have two different options to run the Helm charts. You have the no proxy and no vault, and the proxy and vault. So if we open here the values file, sorry, the values folder, and I open the proxy and vault folder, here I have 5 files. One of which are used for a different chart, but these are templates that are already here, and this is what they look like. So it's very basic configuration here. I'm just setting here AWS as my cloud provider because I'm using AWS. Here is the Kubernetes URL and the Vault, some configurations related to my Vault instance, such as the URL, the secrets engine, and where I do want to store the crypto materials for this specific participant. I'll show you later on the UI how it looks like. And yeah, so if we run this, let me open the Besu Genesis Helm chart folder. So basically, here we just run a job Kubernetes job in which we set the Genesis Genesis file, and by using well, here it saves or it stores the crypto materials generated on our Vault instance. We are creating a wallet for if you run these Genesis job, but if you want to use your own wallet, you can use it later when we're going to send transactions or private transactions actually. So yeah, this is basically, it's a very simple chart. Also config map, which we are saving the boot node file, the Genesis file, and the static nodes file. So I'm gonna let me go back to the README file, and I'm gonna run this command. Okay, so now so now we only have the Besu Genesis init job for deploying for generating the Genesis, which was actually already generated, but the Besu node that will be spin up right after this will need it. So that is there, and also Bevel Vault management job for storing the secrets on our Vault instance. So now the next step is to run this command. I'm going to run it now, and then I'm going to explain this. It needs some time for the Besu node to spin up correctly. But basically, we're using the Besu node Helm chart to deploy our Besu node and our Tessera node that I'll explain you now how. We're passing as an argument this transaction node secondary file. So if we open it, here we have again some this configuration. You have it in the repository. You just need to adapt the file according to your Vault instance if you're using one, or according to your cloud provider, and the different settings you might need for your business case, POC, or whatever. So again, cluster AWS. Cloud native services is false. If I set it to true, it will be using, in this case, AWS Secrets Manager, but as I'm using HashiCorp Vault, I don't need it. Here we have the configuration related to Vault, which is the same as the one for the Genesis. Here I'm giving an external URL suffix to the services that are exposed for my Besu node, which are the RPC URL, and I think WebSocket is also exposed, and the storage size for my Besu node. In this case, 2 gigs for me is enough, but maybe if you need more, you just can modify this. Here is the important part, the setup. So we're gonna enable privacy for this node. So we are gonna be deploying a Tessera node, which is gonna be connected to the Besu node. So here I am listing the 2 other Tessera nodes that we already have. All right, so if I quickly show you, it might not be ready yet, the Tessera node for entity 3, but I'm showing you the logs of the Tessera node for entity 1. So here we are getting an error. It's not a breaking error, but it's just telling us that the Tessera node for entity 3 is not reachable, which makes sense, right? Because it's not ready yet. So once we have our Tessera node deployed for entity 3, this error, this warning actually will not be printed anymore. So just wanted to show you this. Again, some other settings that you might modify according to your needs, such as the storage size for Tessera. It's some TLS configurations you might want to enable if you are using SSL connections. And here is some other configurations for the Besu node. The Besu node also exposes an endpoint to get metrics. You might use Prometheus or some other monitoring tool to get all the metrics that are exposed by the node. So you can set it to true here. And also I'm using this image for Besu. Maybe it's not the latest one, but yeah, it's the one I'm using. So you can modify it here as well. So let's check now the pods for entity 3. Oh. Okay, it seems like they are running. Let me see if the Tessera node for entity 3 is available. Yeah. So now if we check again the logs for entity 1, this error or this warning is not being shown anymore because the Tessera node for entity 3 is already there. So now we have all the network components we wanted deployed on the EKS cluster we are using. Again, this might look a bit tedious, but we have other webinars in which we follow step by step how to deploy the validators, and it's very easy to follow. Here, for the ones that are a bit more experience with, or have a bit more experience with Hyperledger Besu, in the Besu node chart, this might look familiar to you, but here we're running the Besu binary, and we're passing this config toml. This config toml contains, let me see, yeah, contains all the settings that you might need to do manually if you're not using Bevel to deploy your Besu node. So here it sets some P2P and word configurations, some JSON RPC configurations, GraphQL, WebSocket, some things you might need to set properly your Besu node, privacy, some privacy settings, and the metric settings. This is everything done by our Helm chart. So depending on what we set on this value file, it will set some things to true or to false. So if we set the privacy to false, we won't have privacy. So some configurations might change in that config toml file. And yeah, that's it. In this service file, we are exposing the RPC endpoint for the Besu node, so we can access to it in an easier way. So going back to the slides, this we have already this, and now it's time for us to cover the main topic of this presentation, which is the privacy feature in a private DLT network, which with Hyperledger Besu. So it's very easy to follow. Basically, what we're going to do is we're going to send an RPC request to one of the Besu nodes, let's say, for example, entity 1, and entity 1, the Besu node for entity 1, will send the private transaction to the Tessera node that is attached to it. The one that will do that is the private transaction handler, which is a component of the Besu node, but here the keys represent the Tessera node. Just wanted to mention that, yeah. But yeah, so the Tessera node, this will be the origin, and we will set a private for in which we will be sending the private transaction to the Besu nodes we want. So for that, we have to specify in that private for field the public keys of the Tessera nodes for the receivers. So in step 3, the receiver will get the private transaction, and the Tessera will store the details of the transaction encrypted. I think it uses RLP encryption, not 100% sure, but it uses internally a SQL database, so it stores the details of the transaction, of course, encrypted. It's stored there. So once it's stored, in step number 4, we go to the picture in the middle. Once that's done, a private market transaction, which is the PMT, is generated, which is basically a hash, a public hash that everyone will see that represents that private transaction. So once that PMT is mined into the corresponding block, the transaction will be propagated. So everyone could see, or everyone will be able to see these public details of the transaction, right? So we go to step number 6. If we try to retrieve the private details of that transaction, only the ones who were part or who were involved in that transaction will be able to retrieve the details of that transaction. How? By asking the Tessera node and querying the SQL database that it uses internally. So entity 1 and entity 2 in this case will be able to retrieve that data, but the one who will not be able to retrieve it is entity 3 because it was excluded from these transactions, so it doesn't have an entry in its Tessera node. So once this, now that this is explained, we're gonna jump to our code again. I'm gonna close this. We're not gonna use the Bevel source code anymore. And I have prepared some JavaScript files to do this. First of all, I want to show you the smart contract we are going to use. It's a very basic smart contract. It just has a create variable method. So we're going to be creating a variable. You can also edit a variable, and you can get the value of that variable by providing its key. So as you can see, it's a very basic smart contract. This is the one that we're going to be using, and we will see that the entity which is excluded from the transaction won't be able to see what's going on. So yeah, for doing this, I have prepared this JavaScript file. So I'm pointing to the RPC node, sorry, the RPC endpoint for the Besu node for entity 1. And we're gonna send it to entity 2. So the one which will be excluded is entity 3. We're gonna use Web3.js Quorum because this is a library which has an interface called priv, which allow us to send private transactions and for this specific scenario. So first of all, I need a private key of a wallet. So I'm gonna go to HashiCorp Vault, and this is the first thing we see. Here I have all the 3 entities and the validators. Again, in a more decentralized scenario, we won't have all of these entities. So if I'm entity 1, I'll be only having my crypto materials or the crypto materials for entity 1. I want to be having the rest of them. So here we have some crypto materials for the Besu node, for the Tessera node, and some TLS certificates. So here, as I mentioned you before, we create a wallet for you. So we're going to use this private key to send or to submit a transaction. So I'm going to copy that here. I have to remove the 0x, I think. And now the important part is the Tesseras, the Tessera nodes. So as the Besu node is the sender, it makes sense to use the Tessera node for entity 1. So I'm going to copy this public key of the Tessera for entity 1, and I'm going to put it here in the private from, all right? And the private for will be the Tessera node for entity 2. So we have to just copy the public key for the Tessera node of for entity 2, and we have to set it here. We save this. I think I'm not missing anything. The private key is here. So if I clear this out, and here if I run the deploy contract, this is again a very basic script for testing privacy. But if I run this script, we are deploying the contract on our network. So it has worked fine because the status we see is 0x1, and the contract address we get is this one. So here is where our contract has been deployed. And And this is the address we're going to be using to interact with the contract. Here we see also some private from, well, the private from, which is the public key for the Tessera node of entity 1, the private for the Tessera node for entity 2, and the privacy group ID. All right, you can create a privacy group beforehand, so it will return a privacy group ID. So imagine that you have 10 entities that are part of the same privacy group. It's a bit boring to be writing 9 recipients, right? So instead of this, you can use just the privacy group ID, and automatically this Tessera node will know where to send, or to whom send the private transaction. So you don't need to create an array of 9 different Tessera public keys. You can just use the privacy group ID. So now I want to show you that here, if we check the logs of a the Besu node, it can be the validator, or it can be a different one. Let's use another one, Besu node entity 1, for example. Okay, here it was, if you remember, it was 5. Now it's 6 because we deployed the Besu node for entity 3. And here in line, well, in block 815, there's a transaction included in this specific block. The transaction is the one for the deployment of their smart contract. So if we get, it's 815. So here I have a Postman collection in which we basically have RPC methods, right? So if I put, was it 815? So if I get the details of this specific block, I'm pointing to the RPC URL for the entity 1. But if I run this, I get public information about the block, right? Which is the number, some other information that we might be familiar with, the miner, the difficulty, the size, the gas use, etc. And here we have the transaction. This is information that everyone can see, but only the ones who were part of this transaction will be able to see the details. And that's what we're gonna see now. We're gonna create a variable pointing to this is smart contract, and we're gonna, as our privacy group is, the members are entity 1 and entity 2, we're gonna see that both entities can see the details of the transaction, and entity 3, which was excluded from this privacy group, won't be able to see private information, although this entity can see public information. So the create variable script is, again, more or less the same. It just here it just calls the create variable method, and we have to pass a variable name, and a variable value. So let's say that we're gonna create a variable called language, and the value for it is gonna be, I don't know, Germany. All right. We have to use the contract address that we got here. The contract address, we have to set it here. The privacy group as well, privacy group ID here. And as we're going to use the same wallet to submit the transaction, we're going to copy the private key. All right, so from entity node will be the origin of the transaction. Basically, we're gonna use this node to send the private transaction, and it will send it to the Tessera node for entity 2. So here I have to copy the same thing, private from and private 2, sorry, private 4. All right, I already did it, already done it. Okay. So this should create the variable. So now we're ready to run this script, which will be creating a variable for us. Okay, so this is the received from the transaction. So here we can see the from. This is the public address of the wallet we used. Here we see the status, which is 0x1, which is it might tell us that it went well. Again, the same private from, private for the keys of the Tessera nodes and the privacy group ID. And here we see as well the block number, which is 0x355. So if I check this again, in block 853, a new transaction was imported. And here we have as well the hash for the transaction. Let me see, I think it's this one. No, sorry, this one. Well, it's the same actually, yeah. So it was block number 853. So we're gonna query this again. Instead of entity 1, I'm gonna use entity 3, for example, just to change it a little bit. So here we see the block and the transaction that was imported in this specific block. So the hash is 0x9A03, which is the same as this one, right? 0x9A03. So we're gonna use this transaction hash to see what can we see depending on the and on the entity we are. So for doing so, we have this script, which basically here we put the transaction hash, and we are going to try to get detailed the private information about this transaction. So I'm going to use entity, let's say entity 2 now, which should be able to retrieve the private information of it, because again, it's a member of this privacy group. So if I run this get private transaction, it's going to give us the details of it, right? So these are the details, and if we copy this and we go, I'm going to do it this way. If we go to a converter here, we can see that the details of the transaction correspond to what to the transactions we submitted before this. So language is German, right? So if we instead of running this script using entity 2, the entity 2 RPC endpoint, we use entity 3. This entity shouldn't be able to retrieve the details of it because it was not part of the privacy group. So if we run it again, we can see that the transaction received is null, right? So imagine, well, now we're gonna, instead of getting the details of the transaction, we're gonna retrieve the value of that, of the variable we created. So I'm gonna copy again these things here, get variable. Okay, and the variable was language. I'm going to use entity one, which should be able to retrieve the value of it. So what we're doing is we're passing, we're again calling or using the Web3.js quorum library that has a call method in the priv interface, which will allow us to pass these details, which are the, okay, I have to update the, oh yeah, it's updated the contract address. Here's done. We're calling the get variable method from the contract, and we're passing the name of the variable we want to retrieve. So if I run this script, I get this hash. So if I copy it and I go back to the converter, I see that it is German, right? So instead of imagine that the entity tree somehow knows now knows the contract address, because here actually in the public information we see that the two is hidden. This is done by the Web3.js library. Instead of the smart contract address, you just writing a 0x000000 address just to hide the destination, which is the contract. But imagine that this node somehow has managed to get the address, the privacy group ID, the variable, and knows about the logic of the contract. So it tries to, so this entity tries to retrieve the value of it. So if we change it from entity one to entity three, we are going to see that it is not able to get any transaction receipt, or it's just not available for this specific entity, as it was not part of the transaction or on the privacy group. So even though this entity knows some details about the contract or the privacy group used and everything, it won't be able to retrieve the data of it, because as well it doesn't have a private global state that is shared between the participants or the entities of that privacy group. So yeah, going back to the slides. Sadly, Tessera has now been, well, is in a sunset phase by Hyperledger Besu. It's still usable, but I guess they will deprecate it over time. So, well, if it's not already deprecated. But it is a great tool to get to know how privacy works, these private states that participants share between them if they are part of a specific privacy group. But you might see yourself in a project in which you might need a more complex privacy. So that's why I want to talk about Paladin. Paladin is a new project developed by Kaleido. It's part of our labs repository. It's in a very early stage actually, and it's way more complex than Tessera. It actually implements the privacy, and you can actually do what we've done so far with Tessera. So you can create private smart contracts, you can create private groups or privacy groups in which the entities share a private world state between them. But you have other cryptographic methods or other roles, such as the notary role, which is more or less the same as, well, or similar to Corda, let's say, in which probably a defined entity is gonna accept transactions that are submitted into the network. It's more complex than an observer role. So again, it's able to refuse or accept transactions, and also implements zero knowledge proof as a cryptographic method, which is a really complex cryptographic method, but you don't really need to understand in detail how zero knowledge proof works, and it does the implementation for you. It is really helpful to hide uh, the transaction details between the different entities, and which are the real world scenarios in which you might need to use Paladin. Well, it might be useful for you if you are in a bond issuance project, or cash payment solutions, or even token transfer, or even a wholesale CBDC. Actually, well, Paladin has an example folder in which you can follow. They have these scenarios implemented, probably in a very basic way, but they use their Paladin SDK to submit or to use the privacy for these specific real world scenarios. So you will be able to see how privacy looks like. And also, Paladin has a user interface in which you will be able to see the details of the transactions that you are part of. Again, it's in a very early stage. I think it only has like maybe 6 or 7 months, but they're evolving it very quickly. They have even a README file in which you can deploy a couple of Paladin nodes and Besu nodes on your kind cluster. It's more of a local environment instead of for deploying the Paladin nodes on the cloud. Although you can adapt a little bit the source code to do so. But yeah, they have a walkthrough to deploy some Paladin nodes, so you can test the privacy and see how privacy looks like with Paladin. And yeah, I think there's a meetup coming up tomorrow, if I'm not wrong, which is a bit technical, might be useful for developers. I encourage you to assist. I think it's going to be great for us. And they're also developing Paladin according to the demands of the community. So I think it's great to be involved, and yeah, it will be really feel helpful for the community. So to wrap up the meetup, we have a Discord server. Decentralized Trust as a Discord server in which you can ask or drop any questions you might have related to Hyperledger Bevel, Paladin, or whatever DLT you're using. Me and other maintainers, Subhajit, Sona, will be there to assist you in the way we can to help you help you with the deployments or any other questions or you will have. And we will automate Paladin, and we will implement Paladin in our Bevel source code according to the demand of the community. So if we see that people are still using Bevel and Paladin is getting a great feedback, we will really consider to implement this and have it ready for you to be deployed on a cloud environment or on a cluster hosted in the cloud. So yeah, this is basically it, David.
Great. Well, thank you, Alvaro. And if there are any other questions, as Alvaro mentioned, we are always welcoming you on Linux Foundation's Decentralized Trust Discord server, so feel free to join us there, and many channels where you can ask questions about Besu and Bevel and all the other projects and labs going on in the community.
Mhm.
And Alvaro, if you could share your slides with me, I'll send an email around to everyone who signed up, and I'll send the slides, the GitHub repos, the recording, the link to Discord, kind of all the different resources.
Yep, I will. Yeah.
Great. All right. Thanks, everyone.